Hey, welcome back to another episode of our 8-bit virtual console series. Once again, I have lost track of what episode number we're at. I'm going to guess 16. I was wrong in the last one, so I'm thinking I need to move on one. 16. In any case, in this episode we're going to build our cartridge, and that's the next step before we can really use the sprites. We need a way of getting the sprites into the console's memory space. And loading code and things into memory space. So we're going to build a cartridge basically. If you recall, we created a cartridge.json file. It doesn't have an editor, so we're going to create an editor for it. Before I do that, I just want to show a quick thing I changed. So one, I did a bit of refactoring of some of the code that we output for the sprite editor. Not finished, I'm not tied up the visuals yet. The main thing I did, though, and I didn't do this on the camera, I kind of wish I had, but it was one of those things I just started with breakfast as a tinker thing and kind of finished it. So I've basically now got multiple file support for assembler code. So main.asm, I'm including loop.asm and jumping to loop, and in loop.asm I've got loop and the loop it was. You can set breakpoints in here. It should go away when we move files. Yes, that was quite painful to get right. And if I run it, it should assemble it okay. If I run it, we should hit the breakpoint, and we've set the first AA in our memory space as we expect. So that was just a little kind of change I did because we're starting to write more complex programs, and it's getting, putting it all in one giant file hurts my brain even more than assembler hurts my brain on its own. So we've got the ability to kind of split things out now, and that will allow me to kind of also build up some little packages of things we can include, like a little sort of almost like a package manager, I guess, of assembler we can include for common things. So we've been doing stuff with a linear frame buffer so far. We can include some of those utilities: circles, rectangles, lines, and very useful things to be able to include. And the build system obviously understands that and can pack it together. I created some new tests for that, so our assembler has a bunch more tests for multi-file assembly, and the existing tests all work, which is great. So between episodes I created that. However, we're going to do this cartridge system in this episode. So I want us to first off define an editor for how the cartridge is to be built. And essentially the way I'm thinking of a cartridge, if you think back to when we talked about memory layout, it has bank switching. And in fact, things like, I've not really showed it, but things, if we go to the memory layout, so again, spin ahead a little bit to the sprite system. If we go to the memory layout, sprites, where did I put them in the end? Sprites. Oh goodness, they're not here, are they? I need to go to my sprite spec. Sorry, sprite spec. I can't find it. Where did I put it? Sprite count, sprite enable. Somewhere. Have I lost it in an edit? Maybe. I'll need to put it back. But essentially, in here, we need to be able to say the sprites come from this bank of the cartridge. I'm pretty sure I got the so tile map graphics bank. So tile maps are also our gbin files, our graphics files, and you can essentially, for a given level, point the tile map system at a graphics bank, and it'll pull the graphics from there. So our cartridge is essentially a set of 32K blocks of ROM, of read-only memory, that we're going to load up. And I've got some sort of sense of two fixed banks in this. So bank 0 is basically some metadata, and we'll also put a loading screen in there. And the metadata, so to begin with, will simply be where to load the code, because our code is based at a position in memory. And then item 1 will be, bank 1 will be our actual source code. Our source code will get loaded into RAM. I'm just going to pause there for 1 second. We'll be right back. Okay, I'm back. Had to pop downstairs quickly. So that's item 0 and 1. Beyond that, we're going to let people map the asset files into banks. So you can say, bank 2 is, I'm going 0 based. Bank 2 is sprite bank. 3 is levels, a level, a tile map level, etc., etc. And then at the end of that, we're basically going to be able to build a cartridge, which is where we take all that data, we pack it into what I have called cartridge.rom down here, cartridge.rom. So just make sure everything's 32K aligned and packs them into this file. Obviously back in the actual 8-bit days, 32K of ROM was quite expensive, and bigger cartridges would cost more to manufacture, so there'd be a lot of focus on keeping things small. I'm not really worrying about that here because 32K cartridge is not expensive for us to manufacture. In fact, I think we've got because the bank selectors are bytes, we can have up to 256 banks of 32K RAM, and I think that's 8 megabyte maybe. So that's the biggest our cartridge could get and be usable by our 8-bit system in terms of the number of banks. So I'm not massively going to worry about that for now. You know, the palettes, for example, they're not going to take up 32K, and you know, if I was working in the 80s, I'd want to find a way to not waste the rest of that memory. But I'm just not going to worry about that here for now. Perhaps we'll do some interesting things later. In any case, we're just going to output this into our cartridge.json file. I've just given it a sense of how to do that, and then building a cartridge. Essentially, we just want to take all the assets and pack them into the cartridge. You'll need to assemble a code to obtain the code.bin asset. And finally, when we run things now, it's obviously slightly different. We want, rather than just assemble and go, we're going to load our cartridge up, and we have to do that because when we get the sprite hardware working, we have to have that cartridge kind of ready and good to go. Now all we're going to do in this episode is take the code that's in bank 1, our code, and move it into the right place in memory and start things up. Position program counter, start the MI10 switch to run debug mode. So we just want to start things up. So I'm going to do this in 3 phases, and we'll start with phase 0, phase 1 rather. Yeah, so let's give this a go. There's the file, added it here. Just copy that path. Before I use Claude, obviously I've set Claude up already, as I often do. Let me just make sure I've got a commit point. Cartridge spec, git push, okay, and then let's go to Claude, read this specification and begin to implement a phase at a time, pausing between for me to test and review. Okay. I just want to give it a couple of notes. Actually, I've decided I want to get another note. Okay, so in here, create this editor in editors. Okay, copy that. Cartridge. Okay, and do we need to get any more information on the builder? I was thinking, does the builder need to be part of the hardware, but probably not, because it needs access to all the assets that come from the IDE. With it's an IDE component. Way to put it? It's not console integration. It's services. It's a service. Okay, so create this bundler in this is slash cartridge bundler.ts. Okay, fine, that's better. Let me just commit again. Okay, cool, great. And there's called, and we're going to let it go. As per usual, I will snip this if it takes a long time. It might take it a little while. Okay, so it thinks it's finished. Let's have a look at it first. Let's go back to here. I'm just going to refresh things. Okay, should we to double click this? Okay, interesting. Right. There are our, I mean, it looks quite nice, and it looks like our other stuff. That's our style guide working quite nicely. Okay, great. And we've got a default.gbin and a default.pbin. So we should be able to pick those up and nice, drop them in. Okay, can reorder. Great. I mean, that's really what I wanted. That's fantastic. Great. It read my mind. Mostly because we spent a lot of time writing lots of specs and making code follow the specs, and it does kind of compound. The more examples it has, the easier it is for it to. Basically, the more examples it has, the more patterns will have to follow, and the more things will converge. I mean, I think we saw that with some of the assembly code we were getting it to write. The more examples I gave it, it was able to use as examples to produce further output. So great. We've not done the saving yet, so I'm going to ask it to continue. Well, let's just check it. It should save here. It just shouldn't build the. It shouldn't build the ROM. Now, what do I say about this? Yeah, fine. It doesn't build the ROM. Saving doesn't build the ROM. That's correct. So if I save it, okay, shut that down, reopen it. Okay, and then if I was to go to here and say code. Let's open My Awesome Project again, because we're still working with My Awesome Project. We should have it here. Yeah, great. It looks how we wanted it to look. That's fantastic. So that's a really good start. That's a great start, in fact. I'm really happy with that. I'm going to move palette up there, prefer the palette first, save it. And let's see what happens if we get to move on to the next phase. Okay, so I'm going to create a little commit point here. I know I don't need add star, it's just force of habit. Okay, pop that up, and then we'll go to Claude and say, that works, great, continue with phase 2. Now this should be pretty simple for it. It's got, we've kind of arranged the files in a way to make this straightforward, almost as if it was a plan. Almost as if it was a plan. Almost as if I knew I'd have to build a cartridge with bank switching. So hopefully this isn't too hard for it. It's just to integrate the assembler to build the code, but we know that works. It thinks it's built the cartridge. It's going to be hard to verify at this stage because we can't run the cartridge, but in theory, there's a build button, I press build, and a cartridge.rom should appear. Build successful. Okay, great. I didn't really want to see that. Is that size right? Let's have a look. So 131072 divided by 86. Yeah, that's correct. 4. Didn't recognise the that. It's a long time since I've worked in small numbers of bytes. I didn't recognise that. Okay, does it appear in the project thing? It does. Okay, we don't need the alert though. Okay, so please take the alert away. And this shouldn't do anything. Fine, it'll never be editable, so we'll do something about that at some point. I mean, it might be editable. It might be useful to display a hex explorer. Yeah, it might be useful to display a hex explorer, but we're not going to do that now. Can you remove the crusty alert. That's really grim. That's really grim. I wonder if we get to do a toast notification. Okay. Yes, a toast notification. Could we introduce a toast notification? I don't know if we've got toast already installed. I can't remember. I don't think we have. I installed toast on another project the other day, so I think I'm getting myself confused. I never understood where toast comes from. Is it because they pop up? It could have just used the toast package, but we'll let it bumble away. That's my bad for being too what's the phrase? Too loose. I'd rather just picked the toast package. But never mind, it's okay. Again, we can swing back round and say replace the custom toast system with this toast package, and it'll do that quite happily, I think. Yeah, I guess it's because we pop up. I've never thought about that before. The things you think about or don't think about, more to the case. Yeah, so as well as building the cartridge, we're buffing up our IDE yet further. So that's cool. I like this. Although step freezing with a scary one. I say that, it should be okay, I think. Let's go back to Edge. Where's Edge gone? I'm looking at my taskbar, which you can't see. Let's build it. Okay, great, fine. I will get to replace it with a proper toast system, because that's not very attractive, is it? And I'm not going to spend time making it attractive. I can just use the toast package. Okay, that's good enough for now, though. Great, so we've got that. I want to just update the spec a little bit. I've realised something. We should rebuild the cartridge and copy it. Right, I've updated, so okay, so let's just save. I'm hopping around all the place here in my head. I do apologise. I just need to save a commit point. Move to toast style notifications and building a cartridge. Cartridge building. Okay, git push. Okay, great. So I was going to say to it, I've updated the spec for phase 3 slightly. Please read the updated version and proceed. Okay, so I don't think I talked about this earlier. So essentially I wanted to update the run system so that when the run button is pressed, at the moment it's a bit weird. It runs it, but it's not actually running. You have to press the run button inside the debugger. I just wanted to run it, to load the cartridge and run it. So I've basically changed things so that when we press run, it just goes. Loads the cartridge and goes, which is all we really want. Yeah, that's all we really want. But let's see what Claude's doing. While this bumbles away, is one other thing I wanted to add to tests, because I think it's where the sort of confusion comes from about tests and other things that seem strange to me sometimes in software development. The job of developers is not to write code, which sounds a strange thing to say. The job of developers is to create solutions to problems inside constraints. that's fundamentally the job of developers, and I guess that's the job of engineers. And you have to be mindful of those constraints. You should challenge the constraints. Somebody says we need this yesterday. We need this in 3 weeks' time. A very reasonable, and it's sort of 6 weeks of work. A very reasonable question to ask is, or even if it's 3 weeks of work, a very reasonable question to ask is, why do you need it then? Is there something we can do to make this a bit more low risk, etc., etc.? So the constraints should be challenged, but the role of developers are not. It's not the job of a developer to create code and tests. It's to solve problems in the context of constraints, and I think the focus becomes so strong on code sometimes and tests for code. People get because most of the developer's life up until now, I'm not spending much time in code here, but most of the developer's life, in the past has been about code and tests, but we get very focused on it, and rightly so. It's a complicated thing that we need to understand deeply, but it's not actually the job in some ways. It's a means to an end. Doing that is the developer equivalent of project managers focusing only on process and confusing process with the outcome, which happens a lot. And my favourite thing, Jira. I cannot stand Jira. Jira is like an embodiment of that, and the way people work around Jira. It becomes this ritualistic thing. The process, the Jira process. It's like, well, that's interesting, and the process might help us get to the outcome, and sometimes it might not. But the process and the policing of the process, and that project manager, I'm sure we've all worked with project managers who get obsessed with the process, and it has to be just so. That's not their job. Their job is to facilitate reaching an outcome within constraints, the same as an engineer solving a problem to meet some constraints. And people in my experience, often confuse these things. I did when I was, I guess I want to say younger. When I was less experienced perhaps. As I've got older, for whatever reason, I've become ever more outcome focused and goal focused, and I backtrack from that. Which is why I sometimes talk about these things in this session, because I think it's a more useful mindset, I find. In any case, it thinks it's done. We'll see what it's done. I have no idea if this is going to work. Let's see. Let's go to Edge. Okay, so in theory, we've got the code we had before, and it should, if I run it, let's see what happens. It builds it, it runs it. It's all up and running. Okay, that wasn't running before, so that's good. It looks good. Okay. Cool, it looks good. Let's run it, and it's interesting that we can see that. I'm just going to refresh things. So let's go back here, we've got the cartridge, let's run it. Okay, that might be due to when it's loading and catching the snapshot when it loads, I think. It's probably already up and running. Yeah, I think it's already up and running. We should be able to see. Do breakpoints work in this world? Let's find out. We should do, because the symbol maps should map onto where the source has been loaded. Yeah, fine. Let's set that there. Let's stop. I need to clear this outlook. So I'm just going to reload it actually, and go to here. Loop, set a breakpoint, run it. Okay, it's not hit the breakpoint. That's interesting. Okay, so that's not quite right. But the source mapping's right, because we could see from where it was at. Interesting. I wonder if I was to, well, it's running, if I was to just do this again, run it, go to the source, if I set a breakpoint here, would that do it? Yes, so a breakpoint is symbol mapped, okay, because we know it's at the infinite loop. I can set a breakpoint and it stops. But for some reason, I think the breakpoints aren't loaded before it starts. Okay, so we need to just make that work. Breakpoints. if I set a breakpoint before running things, then it doesn't get hit. This is 1 second. It's just one more thing to see, to just demonstrate where this is at. Is it a loading thing or is it timing? Press run. It's timing. You know, the breakpoints are loaded. It's just when we put one up here, we're too early in the process. It's still loading the breakpoints in before the CPU started. So it presses run. I think it's putting the CPU into run mode. Yeah, it's putting the CPU into run mode before the breakpoints have been set. So it skips past them, you know, early in the code. To the CPU worker. Yeah, it's just a timing issue. But great, I mean, that's our cartridge loading. That's great. I need to go and look at all this code, obviously. Yeah, let's see if it can fix this issue. And I found time to pontificate on this episode. You know, one of my favourite things, pontification. Okay, right, so it's done. I was a little distracted on my other screen. Let's see if it works now. Let's go back in. Let's refresh everything. Loop.asm, set a breakpoint, run. Still doesn't work. So this again, loop.asm, set breakpoint, run. Yeah, not working. Okay, so still not right. Same behaviour as before. It might need one of those like little set timeouts to let things settle in React event DOM land. Okay. Sort of. So it's like we're not going to need a set timeout. I am going to add some tests around breakpoints in my worker once the cartridge is up and running. I won't do it on here because it'll be probably boring to watch, but I'm going to add some tests around this. I was thinking that this morning when I did the multi-file assembly, that the next thing was to with those two systems in place of a cartridge and multi-file assembly, that was a good point to layer a bunch of tests in, and because that system will be fairly stable now. It's pretty much, you know, doing what we need it to do going forwards. It thinks it's finished. Let's try again. Okay, great, that works now. Awesome. And that's great. We can compile a cartridge, and you know, it's working nice. Debugger's working great. I mean, that test screen, obviously. One thing I need to fix actually. Look, if you're on a breakpoint, I found this the other day. If you're actually on a breakpoint and you press run, it doesn't move past the breakpoint. It thinks it's already there. That ought to be something we could fix now, perhaps, as we've got a little bit of time left. I'm doing quite well in terms of time on this video. It's been quite quick, so let me just... Okay, pop that up. Okay, then go to Claude. So I was already in Claude. Okay, can we make a fix to the debugger? If I set the breakpoint on a line, breakpoint is correctly hit, but if I press run in the debugger, what actually happens? We don't move on. We don't actually move on. We just hit the same breakpoint. And the program counter doesn't move. Where's the PC program counter? It's been. Oh, it won't move if we want me to tell, but we can tell from a memory map that it's not. It's not actually executing this loop. Yeah, so we could do a fix on that. I noticed it the other day. I meant to fix it and forgot. But again, I think that's why we're at a really good point now to get some tests around this across the CPU worker and the IDE. We're at a really good point to get some tests around this. Okay, see if that helps. Loop.asm, set our breakpoint there, run things. Okay, we hit it, and we've set 1 byte on the top left. Okay, great, that's it. And if I set one there, let's see. Yeah, great. Okay, so that's fixed our little breakpoint issue. Okay, so hopefully that has been a useful exercise. I think elapsed time for me in this, I want to cut a little bit of a chord out, but elapsed time has been 40 minutes. Basically 40 minutes. So we've essentially gone from we've gone from having no cartridge system to being able to implement a cartridge editor, build the cartridge, and run the code in the cartridge. Again, I think that is pretty cool. We've got there fairly quickly. I think that's pretty cool. And we're starting to feel like I've got a real system here, which is great. Unfortunately, what this means is I'm going to have to draw some sprite graphics, which is where everybody realizes I am not a good artist. I might try and pull some from classic games, particularly as we've got classic palettes. Yeah, great. Thanks for watching, and I'll see you in the next episode where I think we will do the sprite hardware. I'm feeling primed for sprite hardware. Great. Thanks for watching. See you again. Hey, turns out the episode hasn't quite ended. After I sort of finished recording the episode and I went to review the files, I realised we hadn't even looked at the files in the episode. So my brain clearly not working very well. So just a super quick tour, and I haven't reviewed these yet, other than removing some like silly warning things. I haven't really reviewed them, but I figured I'd do it as if we were doing it on screen. As soon as I realised what I'd missed. But essentially, it has put the editor in the cartridge folder. We've got two main files, a cartridge editor and an asset palette. The asset palette is basically looking for the various sort of assets we've got, and it's presenting the palette we saw on the screen, which hopefully is still running. Yeah, okay, still running. So this is the palette, and it just goes and finds things from the Project Explorer. Very exciting. not really, but it does the job. And then we've got the cartridge editor, which is the thing that hosts the asset palette and has the stuff on the left here for drag and drop. And so it basically orchestrates the drag and drop, and then it invokes the cartridge bundler. It does some various setup around the adding assets, but it essentially invokes the cartridge bundler, which is here. I mean, it's very exciting. It builds the banks. I guess build metadata bank we will come back later, but this later because we're going to add some loading screen stuff in. But this is the thing that is basically. God, my brain's not working now. This is the thing that is putting the code addresses in, so we know how to load the code from the assembled code, so it knows where to place program counters and pop the code into memory so that our labels work. Remember, our labels essentially capturing addresses in memory, so when we load the code we have to load it into a place that the assembler assembled it for, so that we can so that the jumps and branches will all work correctly. It builds a code bank, assembles things, it loads assets in, and builds the cartridge, which is the main kind of input to it. Yeah, very exciting stuff. And it's put that as I asked it to in the services folder. Yeah, so I am going to take a bit of a review of these things. My main concern from a glance is that these things are quite big and complicated, particularly cartridge editor. So I might see if we can pull those into smaller components. The cartridge bundler, I think I need to review exactly what it's doing. I mean, it seems to work. We've not exactly pushed it far. We've not done sprites and things yet. So that will be interesting. I mean, it's not. We in fact we asked it not to do sprites. It's just doing the code right at the moment in terms of how it gets loaded anyway. So we're not testing any other aspects of its bank sharing, other than that it reads bank 0 for metadata when we load things, and it moves the code from bank 1 to the right places. We know that works. We do know that works. So yeah, I'm probably going to go through this a bit more of a fine-tooth comb, and I will, I think, also write some tests for the cartridge bundler, because it's clearly something that has to be very carefully laid out, presented, etc. And I think already it merits having tests around it. I think I mentioned also some tests around breakpoints and things too. So I will probably do those things between episodes. But maybe we do a sort of sideshow create the tests episode. I'll see how I feel and when I can get them written. Yeah, so I just wanted to add this on at the end. There's a file if you want to look at them. They might have changed by the next episode as I do actual review of them. Yeah, thanks a lot.